It's day 2 building the FC1 jet. We've already installed all the servos into our flight surfaces in the first video. Today we're working on the fuselage. To be more specific, we're working on the thrust tube, the whole vector system that makes this a 3D jet, and the full flying elevators. As mentioned in the last video, there's no hinges, so it's a full flying elevator. So how does it attach to the plane? Well, we've got this carbon tube which slots in here. We've got some bearings so as it can turn nice and easily, and we just slot that in there. It's controlled from the servos using these metal arms which clamp down onto the tube, but they also have this little hole in the top which coincides with a hole on the carbon tube, which allows us not to have to retrim the plane every time we take the elevator off going and coming from the field. So that attaches on there and then goes to our servo on the inside, as we can see there. Now in the back of the plane there's a lot going on, so we need to make sure we do things in the right order. So it's going to be elevator servos. We then have our tail cone onto which we need to attach our vector thrust unit, which attaches on there like that. And surprisingly, the thrust tube actually attaches directly to the cone itself. So all that fits over there and is screwed down. And then the whole thing placed inside, along with the push rods for the vector thrust. It's going to be a fun day. So first step are the elevator servos, which have now been installed. These are the MKS HBL 388s, which with roughly 68 kilos of torque should be okay for our two elevator halves. The servo wire runs down inside this slot in the back here, so it's out of the way of the thrust pipe. And then along here we've also got our rudder servo wire. So that's the other end of that 1-for-1 connector that we saw in the first video. And that wire has just been taped and glued down so it can't touch the thrust pipe. And then where it gets a little bit closer, I've also added a little bit of aluminium tape just to make sure we have some extra heat resistance, even though with this power box wire it's already very heat resistant in the first place. And this is what our elevator linkage system is going to look like, where we have our servo arm, push rod, and effectively our elevator control horn, which, as we mentioned, has these two bolts which clamp down on the tube, and that central locating pin. Now it's important that we get the geometry right here. The elevators are big, and even though I'm using some massive servos, we want to make sure that we get the most torque out of them. So I'm using a 30mm servo arm, but I've drilled it out and I'm only using 20mm. The push rod itself on this occasion is about 85mm, and we're using the outermost hole on the elevator horn, which once we get all of that installed, looks something like that, which gives us just enough control of movement that we need, and we can make sure that we use all that torque from the servo. Here's a silly little trick for you guys. I've just forgotten to center the servos before installing them. They're now attached to my extension leads, whose other end doesn't have a connector on them yet. Why? Because the wire is overly long, because I want to cut it down once I get the power box in and cut them to the right length. So what do? Do we put a connector on here, which we know we're going to end up cutting off, or do we remove the servo entirely, take off the extension lead and center it that way? How about option C? Take our receiver, plug in a standard patch wire, and we get one of these tridents that we use for making our Futaba connectors up. We plug that into the end there. We're going to get our extension lead and just cut the tips off, just to make sure that there are no loose threads on there. After all, this is a live wire and we don't want anything to get shorted out. And all we're going to do is carefully poke the trident inside each one of those 3 wires. Obviously we're not going to fly like that, but to center our servo, as you can hear, it'll do. And once we're finished, there we go. And there we have it, both elevators nicely installed and working. I did end up cutting out a little bit off of this back former just to make sure that no matter what happened, even if anything did flex a little bit, nothing could ever bind on the back here. And the only other observation would be the screw that I used for the servo arm. Now this may be specific to my particular servo, but I ended up installing it from the back with the nut on the top, which is the opposite to normal. This allows the servo more free movement and it can actually go over the top of its own case rather than banging into it. Joining the thrust tube, vector thrust and tail cone should be relatively easy as it all comes marked out on the inside. So here you have laser engraved markings which coincide with these little lips on the thrust tube. So that all gets screwed into there. And then you can see these other 4 points which have been reinforced, which are for the actual vector pipe itself. So of course that flips on the outside, where we can just make out the pilot holes, which we can use to line everything up with. I'm trying to do this one-handed. And that just screws on there like that. Should be a nice quick job. With the aft section done, we've now got our vector thrust pipe nicely installed. It moves freely throughout 360 degrees, which is perfect. I did end up re-drilling all the pilot holes just to make sure that those pieces of wood that are stuck on the back didn't get pushed through with the screw. Now I did add Sino onto the screws as well to make sure they grabbed the wood nicely. It was a little bit harder than expected, simply because it turns out that the screws aren't magnetic. So trying to get those into the right place down there when they're not magnetic and they want to fall off the screwdriver was fun, but we've got them in there now. I may not have enjoyed those screws, but credit where it's due. It's nice to see that they've been smart and they've used the same spot welder to manufacture the thrust tube to actually lock everything in place. So all the nuts and bolts, which normally may or may not come loose in time because of the differences in temperatures, here are very much welded together. So we know they're not going anywhere anytime soon. And that's the thrust pipe connected to everything else at the tail end of the plane. Even if I did end up cheating and going back to my servo screws with the Allen key heads on them. Much easier, much more magnetic. Still using a dab of Sino just to make sure that everything locks in nicely with the wood and can't go anywhere. If I were to start again though, I would probably do it in the opposite order. So I would start with the long thrust tube first, because that will allow you to sit it upright and then continue with the vector pipe. Whereas the way I did it, installing the vector pipe first, meant that because it sticks up a little bit, you can't put it the other way around because it wobbles all over everywhere. And with our thrust tube sorted out, it's onto the vector thrust. That obviously needs 2 servos, one for vector elevator, one for vector rudder. That's what it looks like when we start, and that's what it looks like when we've finished. Couldn't be easier. 4 screws into the hole. I've gone for the MKS HBL 550 again, so that's the same as the flaps. With its 38 kilos worth of torque, should be plenty for our vector thrust and be able to have a load of fun. Linking our servos to our vector thrust system are these very long carbon push rods. One side comes pre-finished by the factory with its ball link ready to go. The other side we can cut down and we just reattach the ball link using this nut and bolt and a little bit of glue. Now, I like the idea of using both the glue and the nut and bolt, but I don't know what the factory has done under the heat shrink. So, I've taken one off. Time to see. Yeah, no glue. So, we'll be taking the heat shrink off this one as well. We'll be adding in a dab of air epoxy in there and then assembling everything back up, ready to do the other end. Probably a little unnecessary, but they're now epoxied in there as well as the nut and bolt. Time to get them into the model. There we go, that's both ball links attached to the vector thrust. But for the second time today, I've done things in the wrong order. This would have been so much easier if I'd have installed them before attaching the whole vector thrust to the tail cone. Oh well, it's done now. And all of that gives us this finished tail unit, where we have attached to our tail cone our thrust pipe, our vector thrust at the back, and our carbon push rods that control everything. Now we just need to slot it through the fuselage, making sure that our carbon push rods slot through their openings, and then we just screw it in place with the 3 screws that we need to attach from the front of the fuselage backwards. Should be easy, right? Well, we'll see. With a little bit of wiggling, wasn't too bad. Anyway, we've centered the vector thrust pipe with some masking tape, as obviously that doesn't hold itself there without the servos attached, and we need to figure out where the push rods need to go. So with that nicely centered, we've got here our vector rudder push rod and our vector elevator push rod, and you can see I've already marked out where the center of the servo spline is relative to the push rod. So that's where the end of our ball link needs to be. Now it's time to remove everything again, cut these wherever is needed so that our ball link can end there, coinciding with our servo arm. And with some editing magic, we've now finished our push rods. We've used a receiver to center both servos and attach the servo arms to them. These ones are the Pilot-RC 1.6 inch arms, and we're using the outermost hole to get the maximum throw on our vector thrust. We've got one on one side and the other on the other. We've made sure that they don't bind anywhere inside the fuzz, so they're nicely free moving no matter what one or the other's doing. And with that, our vector system is ready to go and have some fun. And with all that working correctly, it's time to finish this video. If you have one of these FC1s or you're thinking of building one, make sure you don't make the same mistakes I did in installing things in the wrong order. I would definitely suggest installing the thrust pipe onto the tail cone first, then install one end of the carbon rods onto the vector thrust system, all before installing the vector thrust and carbon push rods into that tail cone as a last step. It would be much easier and you wouldn't end up having to undo things like I did for this video. If you've seen anything that you think could be done better, or that you're surprised with how I've done something, by all means, please let me know in the comments below. I've already received a few super interesting comments and ideas on the last video, and I'll be implementing them at the end of this series. So, by all means, speak out. I hope you've enjoyed this video. If you did, leave us a like, subscribe if you aren't already. We've got a lot of building yet to do, and I'll see you all in the next one.